Hi and welcome back to the course. In this video we're going to do what we did in the last, but with the user model. We're going to be using the SQLAlchemy methods there to make things a bit simpler. Let's start by going to the user model. Now, as we now know, there are a lot better ways of doing this sort of stuff than what we've got here. How would you change this code to return the user that matches the username passed in as an argument? Hopefully you got that, and if not, do pause the video and give it a go. Look at the last video and it will give you a wee hint. But it's really a lot simpler with SQLAlchemy than it is manually. We're going to return cls.query, and that's going to return as the query builder that essentially returns select star from users, which isn't a valid thing. We cannot do that because that's just a query builder. And the query builder is an object which allows us to build queries, and the first part of this query is going to be filter by username is username. This username here is the table name by which we are filtering, and this username there is the argument. It's rather confusing in Atom because these two are the same color, but nevertheless this one is this one. Now that we've filtered, we have to retrieve the one value that we should have returned. There shouldn't be two users with the same username, so we know there's only going to be one, so we're going to get the first item returned, the first row returned, and that gets the first row, and SQLAlchemy then converts it to a user model object. Similarly, with find by ID, we're going to do exactly the same thing. But in here we're filtering by ID, which is the column name, and the value is underscore ID, which is the argument name. Now remember mentioning, I don't like calling things ID because that is a built-in Python method. And in the case of SQLAlchemy, there's no real way of avoiding it. We could call the column underscore ID, but that would be a bit weird when it comes to looking at your SQL database. So it's not a problem if you use it like that, because we're not using the ID method, the built-in method anywhere else. But if we did, then there would be some confusion there. Okay, but this is fine. And now we've got the filtering there. Notice that this is going to be a bit strange, but this user model here is an API. Now, some eyebrow raising moments. This is an API. It's not a REST API, but it is an API, and this API exposes at the moment two endpoints, two methods. The find by username method and the find by ID method. This API, these two methods there, are an interface for other parts of our program to interact with the user thing, and that includes writing it to the database and retrieving it from a database. As long as we don't change the API, we don't have to worry about the impact of our changes anywhere else in the code. And what I mean with that is we are using this API, find by username and find by ID, in the security file, here at the user model. Now we've changed the implementation of our API, but security.py doesn't care, because it's just calling the methods, and as long as the methods return the same thing, everything is fine. So as you can see, our API, our REST APIs are the same. We have our endpoints, and the web or mobile application interacting with those endpoints doesn't care if it's written in Python or in Ruby. All it cares is that it's getting the data back that it requested in the same format that it expects. And this is the same thing. This is also an API. It's an application programming interface. And the security.py uses this interface to communicate with the user and the database. In the case of mobile and web apps, they may use our REST API to communicate with the database and store items and users. So as you can see, the same layout of programming concepts applies pretty much everywhere you look. Now that we're here, I'm also going to add the save to DB method. And you know how this goes. So I would encourage you to do this on your own first, as always, just to make sure to reinforce the concepts. And I'm sure you got it, db.session.add self and db.session.commit. As a refresher, if you want to remove something from the database instead of add it, you would just put delete there. Okay. Now let's go over to the user resource, and we're going to make a couple of changes here that are going to make things a bit nicer. The parser is not going to change because that's part of Flask RESTful, and this resource is concerned with getting the data correctly from the request. So that's not going to change. This here isn't going to change because we've changed the way find by username is implemented, as I just mentioned, but it still returns a user object or none. So the user resource doesn't care how it was implemented. But what is going to change is all this here, because we've now given the user model an extra power in our API. So we can say user equals UserModel, and then we can create the user model from the data username, data password, and then we can just save it to the database, save to DB there. And that's it. Do remember, now that we're here as well, as a recap, that you could simplify this line there. Take a moment to think about how you could simplify this line there. Well, the user model should take a username and a password. Let me check that it does. Okay, the user model right now takes an ID as well, but we don't need that. Apologies. The user model takes in a username and a password. So we could simplify this because this is a dictionary with a key username and a key password, and each one has their own value. So we could unpack this and pass it in as data. And what that does is that essentially does the same thing. It says for each of the keys in data, say username equals the value, password equals the value, and so on. And because we're using a parser, we know that it always is going to have username and password. It's never going to have anything else or anything less. So it's always going to have those two. Now let's go back to the user model and I'll quickly explain why I got rid of the ID there. The ID is a primary key as defined up here, which means it is auto-incrementing. Whenever we insert a new row into the database, the SQL engine we use, SQLite in our case, but it could be Postgres or MySQL, will automatically assign an ID for us. So we don't have to do it ourselves. And when we create the object through SQLAlchemy, the ID is given to us as well. So SQLAlchemy would give us self.id, but when we create the object, we don't have to specify an ID because it is automatically generated. So it doesn't make sense for us to give an ID there. If we didn't want the ID to be auto-incrementing, we could assign an ID, and then that would be used as the ID value. For example, if you guys are familiar with UUIDs, universally unique identifiers, we could use those as IDs instead of the automatically generated IDs. If you're not familiar with what an UUID is, don't worry, just know that you could put in your value there if you wanted, instead of using the generated one. And for those of you that are interested, a UUID is a universally unique identifier, essentially a very long list, not a list, a very long string of numbers and characters and dashes, and that is meant to be universally unique in your application. Okay, so that's everything for this video. We have changed the implementation of our user model, but our resource essentially stays the same. So it's still, Postman should work in exactly the same way, so you can go ahead and try that, and nothing else should have changed. So that's everything for this video. Hope you enjoyed that, and I'll see you in the next one.